You know what we're here for. I'm thankful for Richard to be able to drag me here today from very foreign land in New Brunswick. It gets cold there too, so don't worry. So obviously we're going to be talking about what is mono, what is a zoo, although I think you guys probably have an idea of what that is, how it might benefit you, how you can run new things, existing things in .NET with it. Also maybe a bit of a technical and social aspects of doing this kind of porting work, the kind of conditions it had to get here, the technical things of how you actually do a port like it, trying to create an environment where other ports like it can sort of emerge, as well as what you can do yourself. So you've obviously heard that I'm from New Brunswick. I'm in college. I'm only 21 years old though, so I've been into computers early and almost as long as I can remember. I don't do them professionally, at least not yet. So I want to have an idea here of sort of the audience makeup. How many of you have installed or used open source software? Raise your hand. I think all of you might want to raise your hand because even though you might not have installed, say, something like Firefox or something you might recognize, chances are your system comes with plenty of open source software, ranging from stuff that you won't really see in the backend, like, say, ICU, to things that are quite a bit more well-known, like Apache. So how many of you have, say, filed a bug report over open source software or had to discuss anything with a project maintainer or representative yourself? Raise your hand. Okay. How many of you have contributed to open source software? Now, you're obviously thinking, well, obviously code, but there's other things too. You can do technical writing, translation, community management, and even money. So raise your hand if you've done any of that. And do let me know if I need to stop and explain something. I will try and relate the things to things you already know on the I if they have equivalents. So the answer is a little strange about how it got here, and it takes a detour into the 90s almost. So I was using a server operating system. How many of you remember BOS? So Haiku is a sort of a modern open source re-implementation of that. It's quite nice even if it's sort of its very, very early stages. And I already knew some C# and figured why not be able to run C# things on Haiku, for example. So I had known of Mono's existence for years because I had used it on Linux and it worked pretty nicely. So I figured why not try, say, porting Mono to Haiku. Now I've barely known C. My C is not very strong when I was trying it, but I had nothing to lose, so I just figured why not try it. Well, it almost worked, but there's this tiny last little bit at the end, and I couldn't get it to work all the way, but I made significant progress doing so. I suspect it was something related to maybe memory management or just like threading, for example. But maybe one day I'll revisit it. The interesting thing is I used the power of open source. Someone else had tried to port it a few years ago, and I was able to build off their work when trying my port. So combining the two sort of efforts, I could get farther than if I had just tried to do it myself. As to how this relates to I'd gotten into I about a year ago from a friend of mine. Now, he's actually just a hobbyist. He basically plays around with get from the systems he's used or managed to pick up, but he's never used I professionally. I think he might have reset a password for money once, but he's never used I professionally. So one day he gets a machine and I play around with it. I read about it, sort of how I works technically, sort of what I is like for the users and install base, and I try using it myself, and it's definitely interesting, relearning sort of computing from a different standpoint than the perspectives I'm used to, like say Unix or Windows perspective. And a lot of it is sort of oddly familiar, stuff like Page, for example. So I would have played around with it, and it was interesting, but chances are I would have put it aside and went to try something else that's also interesting and exotic from my perspective. However, he gave me a sort of interesting challenge. He has known other I users who use I professionally and always wanted to run .NET things on I. He knew I had tried to port it to IQ, and even though I didn't get it to work, it was definitely a huge learning thing to try and port something like that. So he said, why not try and port it to I? And instead, even though I had basically no knowledge of I other than a week or two of just basically doing nothing but fiddling with it, I said, sure, why not? Again, nothing to lose, and although I still had the experience of beforehand. So we all figured that nothing would have come out of it. It would be too difficult to port or whatever. But within a few weeks, I managed to get it working, and I didn't expect there would be actual significant interest from my users in this sort of technology. And I've been introduced to communities like Midrange to try and get the word out or just basically talk about it. So there is sort of multiple aspects when it comes to trying to port Mono to a system that you have to consider. Mono is basically usually portable to POSIX-like systems. POSIX is basically the standard that defines what Unix their systems are like, from everything from their libraries to their standard command sets. However, Mono does support some non-POSIX systems like, say, Windows too, but it would require quite a bit more work. How this relates to AIX, or as I like to call it, AIX, is POSIX compliant. It is a little fast and loose with POSIX at times, but it's definitely POSIX enough that you could port things with it. AIX provides an AIX compatibility layer, and even though they don't really do anything to certify it, it's definitely compatible enough that almost everything will run out of the box for AIX. And if it doesn't, it'll just take a little bit of tweaking, but nothing actually too significant. The other half of the system is, well, what CPU does it have? Good news is Mono already supports PowerPC processors on 64-bit big endian configurations. I'll come back to what that means a bit later. The reason why I need to know this is so that a JIT or a just-in-time compiler can turn all the .NET instructions into the native CPU instructions at runtime. If this wasn't ported, you would have to start out with the interpreter, which tries to execute instructions one at a time, which is far slower, and you would still have quite a bit of JIT work to do to port it over. The other half of the machine part is the calling conventions. These are the low-level details that specify how functions are called in the system. The good news is, because IBM, again, were the ones to support Linux Dev 64-bit PowerPC processors, they may say, why not use the same conventions as AIX? Well, not quite, but they're definitely similar enough that almost everything will run for AIX unmodified if they assume the Linux calling convention. Linux has added their own newer set, but almost everything still supports the older AIX-like set. It's not perfect, though, because there are still some maybe PowerPC-specific bugs and other such to sort out, and it's not a high priority for them, but they're definitely accepting and willing to upstream and even sometimes integrate patches and try and help out if need be. But even though Mono does support our CPU and we have significant API parity required, it's definitely some assembly required to sort out any missing bits. Users already familiar with the ILE, the native environment, might be wondering, why not try and port to that? Well, AIX is already kind of a tricky port already. Trying to port it to a non-POSIX platform would be even harder, even though there is a degree of POSIX support in the ILE, but it's definitely not like a typical Unix system, even in the way AIX is. ILEC compilers are kind of far removed from the GCC and LLVM that a lot of Unix tools are used to, even if there is, again, a degree of compatibility. There's also no backend for the machine interface. That is the abstract instructions that OPM and ILE programs target that works like .NET instructions. So you would have to begin importing that as well as any integration to work on the ahead-of-time compiler, which is like the JIT, but it does everything all at once. There are some other assumptions in the ILE that might break assumptions elsewhere. For example, pointers in the ILE are quite different. They're 128-bit, twice as wide, and they're non-integer, which breaks assumptions dealing with pointers in a lot of programs. And this includes not just Unix things, but things even in .NET too, like the PTR class that assumes it has a 32 or 64-bit integer pointer to work with. However, there are other architectures that are currently in research stages, but due to the increasing focus of security, a lot of aspects of them might make it out of the lab and become sort of mainstream. For example, this includes Cherry, which has pointers like MI, 128-bit capabilities. So that could help, as well as changing the memory model in the ILE program to TerraSpace. I haven't looked into that too much, though. There's also build system work too. You'll have POSIX, Make, or Visual Studio project files. You have to write a build system that integrates. And that's not too hard, but it's just more work you would have to do. However, for our other systems similar to the ILE that Mono runs on, but I mean similar, I mean they have similar limitations. For example, you have WebAssembly. It has a security model similar to how the ILE works, but it runs inside web browsers. You also have LLVM intermediate representation, which is how it sort of abstracts the differences between compilers. Mono actually has to use this instead of writing the native instructions on Apple's machines, which, due to their security model, prevents you from writing out the native instructions. As to how you start out with this, to be honest, you just download it, you try to compile it, and see what goes wrong. If you're really lucky, it might just actually work out of the box, but unfortunately, computers. So once you have trying to deal with a problem, it's usually going to consist of editing the source code, trying to figure out what could be the thing to fix it, and recompiling to see changes. And you essentially keep iterating on this until you make more and more progress. Unfortunately, this iteration is a little bit slow on I because Unix compilation kind of hit some pain points for I. For example, Hayes forking and IFS's file creation performance. However, this is what I strongly recommend too. Instead of downloading, say, a file from your site and extracting that, and we're trying to work with that, I strongly recommend, if possible, to use Git or any other version control system. You might have heard of, for example, say, Mercurial, CVS, maybe for an older one, SourceSafe, for example. The advantage of source control is that instead of having to constantly make copies of files, trying to remember what you've changed, trying to manually compare differences, you can actually work with your changes as basically units. For example, you have a commit, which you can change a bunch of files, describe it, and it'll give it an identity, and you can use that to compare things. You can use it to look at the history of a project, and all sorts of change management structure. You can all then have branches to work with all sorts of commits as a whole unit again. The advantage of this is, again, you can work with your history much more effectively than having to constantly keep copying files and comparing them. With distributed version control systems like Git, you can work independently from the project. So you have project upstream, so they don't have to be aware of the changes you're making. You can just work as if you were on your own, and then still keep it easy to publish your changes and pull in changes they've made. So to get it to work, you're first going to want to try and get the build system to work. Usually this consists of two parts. You have, say, a configure script, which will check what operating system it's running on, its compilers, what features it has, and then it'll write it out to usually a C header file to find all the things it's found, as well as make the make files. These make files are part of the build scaffolding. They'll only build what needs to be built. So if something's never been built before, or the source object that contains it is changed, it'll rebuild that and rebuild anything that depends on what it's rebuilt. So the popular build systems are often on Unix Auto Tools from GNU, or nowadays often CMake. Usually what you can do is run the configure script with the flags, any flags sort of informally just by running it, passing it to the configure script as needed. Once you have sort of a combination that works, you can actually change the configure file to add in your tweaks, and you can just place any sort of tweaks you needed for all adjacent to the ones needed for other operating systems. As for dealing with the source code, for your kind of first pass, you just kind of want to take a brute force approach to just see if you can even get it to work. You can clean it up later, but now you just kind of want to see what can work. And a lot of what you're going to be doing is sort of kind of working around issues and pays where it doesn't implement some things. For example, you have cases where things might actually kind of build all and such, but when you run it, it'll say an illegal instruction. Now, this is usually used where when the CPU runs into instruction it doesn't recognize, but pays will also throw it for a system call it doesn't recognize too. Or sometimes it works, but it doesn't work as expected and throws off things at runtime. Sometimes you might just even run into quirks where it's not even Pays' fault, but long time sort of AIX heritage of being strange. When you're kind of porting this in the C program, you're often going to be using the ifdef feature. And C ifdef lets you set things that are kind of conditional at compile time. For example, if it detected a feature or if it detected an operating system. So you're going to be using this to implement anything platform specific for AIX or I that isn't really standardized, so it needs to be different for every operating system. In Mono's case, this is things like checking the boundaries of the stack. The stack is a region of memory that's allocated implicitly for a function. CPU context switch handling, although Mono isn't one switching out jobs, it needs to be aware of this to jump around parts of its own code. And a little bit of file system info, which on I isn't terribly useful due to the nature of the IFS, but it does help some programs, especially if you're working with remote things. Sometimes you'll have to replace things by stubbing them out just with a little do nothing. In Mono, this is some things related to threading more shared memory. Usually if you're stubbing something out, it's because it's basically optional or it could be made optional, but it's triggering it anyway, so you have to stub it out. You also have to provide alternative implementations, or when something is kind of standardized and available elsewhere, but it isn't available in Pays or AIX. This is often things, say, not available in I7.1 because they haven't been implemented. Pays in 7.2 and newer significantly improves compatibility, so it's definitely considering it worth an upgrade. There's also one case where an AIX actual header file conflicts with a variable name Mono was using. Quite strange, so I just renamed variable. To find these sort of AIX and I specific things, what you're going to be doing is looking at the system documentation and sometimes even the headers themselves. What you can usually do is just Google it. For Pays, even though it doesn't ship the AIX manuals, you can easily find the AIX manual pages that you could reference online from IBM. It'll be easily brought up in a Google search. If you're lucky, sometimes a function that you might need to find is simple to use. It might be just like the other systems, but renamed or takes slightly different arguments. Sometimes, you might not have luck searching online, so you might need to look sort of inside the system. What I use is I try and think of keywords that could be sort of relevant to my case, and then grab the Unix text search tool, set it to recursive mode so it looks inside the subdirectories, and point to the system includes directory. Then I can maybe stumble upon something that could work. Sometimes it's a bit more serendipitous than looking online, but a little bit more error prone. Or looking inside of the libraries, you have the xdump command, think display service program. And you can check what other open source projects are doing too. Chances are they've dealt with similar issues when porting themselves. And so you could study what they do. And this is a bit huge, but if a license is compatible, and you might want to get a lawyer too, because sometimes the license will require some things like attribution or using the same license. It depends on per project, so you should be aware of what license. But if it is compatible and you are willing to take the compliance steps needed, you can actually just copy the code needed wholesale. This is a big strength. For example, I can actually show you trying to look for source code. So GitHub is a popular site where developers share source code and collaborate on projects. So you can use this to search through what open source projects are doing too. So if I found, say, a some weird AIX-specific function, I could look up practical use cases of it online. So let's say I found this function called pthread get threads np. So it'll actually search through, set the code view, it'll actually search through all references of this online. So for example, I can open up, say, this file from the project, say, this looks like Nginx, and see how it's actually using it, this function that we found, and for the codes, any comments, any assumptions. So then, this is actually the case of Mono, for example, using this function. As you can see here, I actually referenced a case where I had to look inside of another open source project to see a workaround for an issue that was in using this function. So, although you can look up, say, not just a function specific to AIX, but say maybe AIX, and we'll look up a function that AIX doesn't have. Maybe someone re-implemented this function and that we could sort of use their solution. So, although we see a little M4 files, for now we can actually filter this to say just C or C++. So we'll filter this to only C usage. So as you can see here, it looks like we have sort of stumbled upon maybe an implementation for AIX. A lot of times, because projects also include other code, sometimes you might get duplicate results because a lot of code does end up elsewhere. But that's just a quick little demo of how you can do code search. POSIX isn't really perfect. Although it's basically standardized a lot of the issues that Unix systems had in trying to be standardized and being different from each other, it does leave a lot to the developers of the operating system too, so they can implement any sort of special sauce they want on top of it. However, there are cases where, say, TTF can improve compliance by fixing bugs, so definitely worth applying those if you weren't anyways. I can think of some specific examples for AIX and I where they either deviated from POSIX kind of unexpectedly or didn't implement something in POSIX. A lot of this is a bit in pays too, because it's only implementing what's basically needed and might not work with some obscure AIX things or just things that aren't commonly used. For example, AIX doesn't like POSIX instead of a System 5 style shared memory. It throws the illegal instruction signal. The reason why Mono wanted to use this is it could keep track of metrics across process boundaries. The good news is, though, that it actually doesn't work on iPhones, so it's already handled in Mono. So you can just pass a flag to the build system and have that feature disabled, and works on iPhone. The AIX doesn't support the newer pthread, POSIX threads way based to get to the boundaries of a stack, illegal instruction. The reason why Mono wanted to know this boundary of a stack is so it can help the garbage collector. This is a part of a runtime that gets rid of all the unused memory without you having to manually free it yourself. So the workaround there was to use an older AIX-specific extension to pthread. A few more examples are getFI headers. This is a function that gets line descriptions in Unix. Pays has a renamed version of this function, but AIX for some reason doesn't actually have this at all. For a while, I was trying to target both AIX and Pays with the single binary, so I had to, unfortunately, use an older version that was a little bit problematic, but does work. DLadder is a function that lets you point to a region in memory and say what library or service program does this belong to. Unfortunately, as a result of this, I couldn't get the crash reporter to work, so I had to temporarily disable that until I could get a DLadder implementation or workaround for it. The syslog is missing on AIX and Pays. That's a function that lets you write to the system log on Unix, or like the system operator log on I, using C's variadic arguments feature. I unfortunately had to create my own wrapper around the normal syslog function as a workaround for that. mkdtemp, a function that makes a temporary directory, is missing on I 7.1. Had to make a custom one just for that. the stat family of functions is missing on I. Well, not missing, but it doesn't properly implement them as expected. So the reason why this is significant is if you have say a file handle that's for a directory, you can have, instead of trying to combine the directory name, which you may not know without because you might have a handle without the name, you can say have a handle then any sort of file name relative to that. So that's why stat is useful. Unfortunately, because it wasn't there, I had to implement it in an alternative way that was a little bit more complicated. Close exec is missing on the I 7.1. This is a feature that, let's see, when you open a file, mark it close on execute. The reason why this is important is because the Unix process model is different from I. On I, you just spawn the process in and it's created fully formed. On Unix, what you do is you create a copy of your current process. In that copy, you can actually do whatever you want, but usually what most people do is exec or replace with another process. However, this sort of replacement child has actually inherited the resources of its parent. This can actually be useful in some situations, but in other situations, you might not want that. So what close exec does is it lets you mark it automatically closed without you having to close it before executing. However, this doesn't work on 7.1, so what you do is you have to mark it after you open the file instead of right when you open the file. Unfortunately, this doesn't work as well because you have a race condition where theoretically you can open the file and have another thread spawn off a process in between you opening and marking it closed. So it's not perfect, but it's better than not having it at all. MAD3 is sort of missing. This lets you give a hint to the system's memory manager that you might not be using a piece of memory anymore, so if it wants to use it for something else, it can. So I had to use an alternative means there. Clock monodic is missing on the I 7.1. What this does is a clock that always goes forward, never backwards. This is useful in case of, say, daylight savings time, and you just want a clock that keeps just ticking up and up and up. So I had to use an alternative means again. Sometimes you get into a weird case. For example, one issue I had was read dir function. This is a thread-safe way to read the contents of a directory. However, on AIX and IBM, it's a little tricky to use because on both the end of directory and an error, it'll actually return 9, just the number 9. And it'll actually, this is spec compliant too. An operating system can do this according to POSIX. To work around it, I had to basically reset the error flag every time I ran it to determine if it was end of directory or error. Not ideal, and not like other operating systems, but it was a way to use it safely. Ucontext is different from every Unix. This is a structure that defines what context switches look like. Unfortunately, functions aren't as well documented, structures aren't as well documented as functions when in the manual pages. So this is often a case where you're going to have to look at the system headers and chase down the structures until you find what you're looking for. And PACE doesn't, unfortunately, try to implement thread or priority scheduling changes. It actually doesn't really throw an error. It just always expects the default values. This hasn't really broken anything as far as threading I'm aware of, but it's nice to know that. Then you have the fact that GCC, News Compiler, is most popular compiler on Unix. However, on AIX and as a result PACE, it can be a little bit quirky, kind of not playing to expectations. So AIX has this variable that lets you set at runtime what the various tools on the system should do if they should build either 32-bit binaries or 64-bit binaries. So all the built-in tools into AIX and PACE, and even a lot of the new ones, they'll respect this, except GCC doesn't. Good news is, though, if you got it from Yama and I, Kevin Adler, actually patched it so that it does respect this. It kind of should have always done that from out of the box, but at least it's better now. And New has their own bin utils. That is, this refers to the things like the assembler and the linker. On I, you would know that is the binder. So they exist on AIX and a little pace, but they don't work terribly well. So you have to use IBM's version of these tools, and GCC will do that. One example where this kind of confused the program was Mono was trying to build something dynamically, but it was passing a flag that really only works with the new linker instead of the IBM linker. When the IBM linker caught this, it wasn't like the other parameters, and it would actually do something completely different and not desirable. Another concern in AIX is the R path. This is a path baked into a program where it'll look for the libraries of the program. As a result, if the R path is broken and it's not finding for things it should, you need to try and correct this in an environment variable, and you can often run into cases where you're just trying to patch over conflicts of even more conflicts, and it's no fun to deal with. Then you have cases where GCC shadows the system headers of its own patched versions. Usually this is to working around cases where the system headers are actually incompatible with GCC, so you might not, it'll try and massage all the that sort of compatibility concern out for you. Unfortunately, this actually broke some cases where some POSIX functions were being removed from the system headers by GCC. So you actually had to look for a real system header, copy the definition of the function you were looking for, and paste it into the header references of the program. You really shouldn't have to do this, but it's better than not having it work at all. Also ran into the case where the C++ standard library was being a little bit fiddly and a bit crashy. I think it was related to, again, something threading related, but I haven't looked into it much because there's not a lot of C++ stuff in Mono. So the dynamic linker in the AIX is picky. Again, the ILE program of linking is binding, and dynamic libraries in I are service programs. So on AIX, as soon as the dynamic linker finds an error, instead of trying the next thing it could find, it'll just give up. This is a bit frustrating due to the way how libraries work on AIX. Unlike a lot of other Unix systems, what the AIX convention is basically, you have the same libraries you use to hold sort of the static modules of a program. It is to sort of link them in the program directly. They can also hold the dynamic libraries too. This is how AIX can put a 32 or 64-bit version of the library in the same file, or sometimes the different versions of the library in the same file. However, this means that you have to address libraries by both the library's file name, but also the member's file name too. Now, a lot of you are basically used to files having member names, but Unix tools aren't really used to having this concept. So one example of this case is, for example, GNU has this tool called libtool for when building things. It can take care of the differences between how dynamic libraries work in systems all for you as a developer. However, because the AIX is different, it gives you two possible conventions. The older one is libtool will first try and put the library, all the libraries and versions into a single file. However, this means that for a program, it actually has to hard code the member name because you can't really do any sort of tricks related to symbolic linking to make file names easier to reference inside of a member. So this isn't ideal, and it can, at least as a packager, means you have to kind of shuffle in files, so you have combined all the different varied versions before. It can get a little bit hairy, and that's kind of why AIX packages are a little bit weird compared to the ones that IBM is now doing for I. Because nowadays, it needs to be added a newer convention to libtool, where it kind of works like the other operating systems by putting the version stuff outside into the file, but still does the AIX trick of having the 32 and 64-bit versions in the same file. This is a lot easier to work with as a packager. And again, RPath is a huge concern here. Again, Kevin Adler, he wrote a blog post, a few series of them, in fact, trying to outlay how the dynamic linker deals with all this. Another mono-specific case was I couldn't get the bomb garbage collector to work properly on AIX. Now, you would think it's been around since the 80s on Unix, and obviously it runs on AIX, so why couldn't I get it working with mono? The answer here is Mono forked the Boehm garbage collector in 2003, kind of extended it, but we've also deprecated it because about a decade ago, they wrote their own garbage collector. It's simpler, but it employs a different garbage collecting technique. However, trying to patch sort of Boehm is kind of tricky because it's a lot of legacy code, and particularly legacy code in the sense that it deals with sort of a lot of assumptions or older operating systems that you may not even heard of, plus the fact that this, again, legacy pre-1990s C code base, so it has a lot of techniques that C programs just don't use anymore, as well as a lot of pointer manipulation that can be very tricky to deal with. However, SGen works. It is a mono garbage collector, and a lot of the newer ports just use SGen instead of bothering to port Boehm, so at least AIX is in good company here. Some other miscellaneous portability issues are the fact that endianness is big. Now, endianness is that the order that a computer stores numbers in. However, most net computers nowadays are little endian, but there's a lot of other non-IBM computers that have big endian too, so a lot of these issues have been dealt with already. And when you do run into one, it's often just a one-line fix. However, it can break a lot of stuff and just keep cascading, so you might not even know where to start to try and find one. A little bit of a trivia question, but on AIX and PACE, a floating point number is, well, for 4 bytes or 8 bytes, just like every other operating system. But on AIX, due to some weird compiler issue from the 80s that they never bothered fixing, and any attempt to fix it would actually break things more, floating point numbers inside of a structure are always 4 bytes, even if you specify them to be 8. This actually broke a lot of assumptions, especially related to calling conventions and structure alignment particularly, where they would expect a 8-byte floating point number to be, well, 8 bytes. Then you have XCOF, AIX's binary format. It's like ELF, for example, on Linux, Mach-O on Macs, and Windows actually uses a relative of XCOF called PECOF. However, a lot of things like compilers need to know what these formats are like, so it can generate executables or libraries on the fly. In most cases, it was an ahead-of-time compiler, which it needed to stuff all the instructions it generated into a library it could load later. Because of the fact that XCOF and IBM's assemblers are quite different, I haven't gotten around to porting that aspect of it yet. On XCOF, you also have to worry about the table of contents, which is the system how it finds code modules find other code modules. However, if it gets too big, it can overflow and cause weird issues in the compiler and linker. So there are ways to work around that at the compiler and linker level. When it comes to debugging a program in PACE, often, I imagine a lot of you do this on RPG too, but you just print out to the console. This is basically a debugger that works pretty much everywhere, and it might all be all you have. So what I like to kind of do if I have to use this method, try and use another method like, say, printing out a call stack or trying to trace the program to figure out kind of a vague idea of where the issue could be, and then sort of keep dissecting it by placing more print statements until I figure out I'm sort of in between where I should be, and then using more print statements to print out variables and such that could be quite different. What helps then is compare the outputs to a sort of a normal system, say your laptop right here. And then it helps to get, for example, a gradient going where you can tell when the error starts to occur. For example, you have, say, an iSystem PowerPC Linux partition to compare with, and of course, say, your normal Intel laptop. A lot of times, too, you can relate the problems that you've encountered on other systems to the problems you're facing immediately. For example, an endianness issue is an endianness issue everywhere. Beyond just printing things out, it's nice to have tools to do it. If you're on AIX, I strongly recommend you use News Debugger, GDB. It's much friendlier than the other debuggers, although it's not quite like Visual Studio. It does have a few minor issues on AIX, but it's definitely better than DBX. On PACE, you'll unfortunately only have DBX, which is the original BSD debugger from the 80s. It's been extended a little for AIX, but it's not as friendly, and it would be nice to have GDB on pays. In Mono, I was running into an issue where if a program crashed outright, it would sort of trash the sort of autopsy of a program to inspect. So yeah, I kind of had to set a breakpoint right before the problem to get the best debugging information possible. If you're on pays, you actually have some more alternative means of debugging. For example, if the diagnostic logs in the system, every time a pays program dumps its core, that is, writes out the contents of memory because it crashed, or if it runs into an unimplemented system call, it'll actually create an entry in the system log. And you have other means like the flight recorders as well, which you can activate for further debugging. This is stuff you can actually do on AIX. So Tony Cairns actually wrote about this on the YIPS wiki. So definitely a lot of information you can take in there for if you run into some serious issues and trying to debug something on pays. Once you do have something working, then it would be nice if you had the official upstream project, the official source code to have our changes, because it is a bit of work to maintain a fork or a patch set just to have your changes. So whenever they make something big upstream that they change, sometimes it breaks other things in your thing. And well, it'd be nice if they were made aware of those changes so that they wouldn't try to break them unintentionally. So the good news is you can try and submit the code to them and try and integrate it. Usually the workflows here are either send patches to them on a mailing list, or if they're on, say, GitHub, for example, you can just start following a pull request, where, for example, a pull request workflow is you have your fork of your repository, you have a branch containing all your changes, and you say, could you please merge this branch containing my changes into your code? And ideally, you kind of want to hope they have a positive view of portability. If the project is just unsympathetic and doesn't really care, then it is kind of a waste of time to try and bother with getting them to integrate it. The good news is, luckily, Mono does have a good view of portability. And making these processes simpler is, again, kind of why we're using modern source control tools. It makes it much easier to, just push a branch instead of constantly trying to figure out what working copy you had, what files were changed inside of it, and all that. The process is basically going to involve code review. We're going to discuss different approaches of how to handle things, a code style, so on. And you're going to keep sort of iterating on this until you get something that's mergeable. From your perspective as the people who maintain it versus yours, I just want to port this thing, will hopefully combine and get an ideal result. When you're done with it, you can put the branch away, and you can basically sort of repeat this whole workflow again and again. Pull request workflow is a popular one for a lot of open source projects. And it's definitely good to contribute to open source software, fix issues, and learn from it, put it on your resume. Definitely gain a lot of experience just doing it on the side. You kind of want to keep working at it too, because the upstream project will change. It is helpful to know the code base when you need to know changes later, so you have a good idea of where to do things and have to constantly look things up. And you want to keep on top of the changes that they make too. You kind of want to engage with the project, because oftentimes they're going to discuss these changes out in the public. So you can express your current concerns on, say, the issue tracker or the mailing list. It helps to maintain a good relationship too with them. You don't want to be just that weird platform that's just a burden to them. Often I find what helps a lot is submit patches that fix bugs in everywhere else too. Again, this is kind of why a lot of projects view portability as a benefit, even if they're not using it themselves, because if they have more users, they can have more people who are aware of bugs and know how to fix them. What helps too is getting the infrastructure too. For example, you might want to get packages working where instead of having the user to build the project from the source code, they can just install a package. Nowadays, for the pays world, what's popular is RPM, so you can create a spec file which builds an RPM package. But then you can also put those packages inside of a repository. So the user can just type in the one command, install the package, and it'll grab anything it needs out of a box. Then what you have is continuous integration. Instead of having to try and triage issues, say, months later when you build something, a new version, what continuous integration does is every change made to the project, or every day or so, it'll download those changes, build the project, run all the tests on the project, and tell you what's changed. Does the project compile now? What errors are passed? What tests are passing? What tests are failing? And it does this, a lot of the whole work of trying to triage an issue and try and bisect it for you. You can know exactly immediately what changes broke it, when, where, who, what, why. Common applications to do this include Travis and Jenkins. For example, I can just show you the Jenkins instance used by Mono. So this is actually the Jenkins page for the AIX configuration here. So we can actually see sort of a trend of test results. Sometimes those dips can be explained in the crash running a test. They happen, unfortunately. But we can see, well, what's different, sort of what issues have resulted and what's changed. And then we can see, for example, what tests are running, and then for any previous tests, which ones failed, which ones now have new success or error conditions. For example, we can just look at a build 2 in detail. So we can see what commits have been made, what conditions cause that to be built, how long it takes, as well as the detailed results from tests as well. So and we see some tests that have failed, and again, we can also click these to see the sort of log of what's been failing, and when I click it, we can jump to exactly when it starts to fail. So we'll close this because I want to also show you the other architectures here too. For example, this is sort of a section I have set up for the community supported architectures. For example, here we can see the AIX one, but also Z Linux. So there's, again, Linux and AIX and Z Linux, and compare both. We also say compare other architectures too. For example, here's the test results for Macs. It's a little bit tricky. Sometimes a little hard to load for me. Yep. See all the tests have passed or failed, and any weird regressions. And then say here's a Linux configurations. Again, you can see exactly what architectures are failing, what system it built it on, so on. Again, this is a lot better than having to try and do this months out. You can basically run it all your supported platforms to test on. Now what I'm going to try and show you is a sort of a very simple and contrived example of how you try and do basically development work in porting. So I'm basically going to show you the whole iteration, getting the recent code in, try to edit code, trying to find code, trying to deal with errors, do some really simple debugging, writing reason about it with it, compile it, and also a little bit about dealing with Git, dealing with branches, committing, reverting, pushing, the logs, doing a diff, and then also a little bit about GitHub. It's not going to be terribly exciting looking, but this is how basically you do sort of development work in the Unix world. Oop, this machine logged out. Okay, so pretend what you saw was nothing, but in this case, we would run, say, git pull to pull in the latest version of the commits and basically try and merge all the latest changes into what we've changed. I'm not going to run this right now, though, because I have a demo environment set up, and I don't want to risk disturbing that. So what we're going to do is pretend we run that, and we're going to build the project. We're going to use the gmake tool, use make tool, and set for 8 parallel jobs. So whenever it can build multiple things at once, it'll do that and run with all 8 jobs. So it's going to just try building. And it's going to start here. It looks like it's going to do some checks here. And so it's now going to start building file. And it's going to emit some warnings that, just cases where it's a little bit sloppy. And, oh, looks like we ran into an error. Or it doesn't look like any sort of just regular error. It looks like it's an exception inside of the compiler. Now, the good news is here that the compiler is nice enough to tell us what file and what line caused the exception inside of it, because this is actually an unexpected case where this shouldn't be happening. Unfortunately, this path is relative because of the 2 dots, so we don't know exactly what this path is anchored to. However, we can take a look at parts of the file that we do know aren't relative, and then look up in where the source code is, try and find this file using, well, this chunk of the path. So we'll look inside where I know Mono stores its class files in the CS class directory, and the find tool will basically find all of the different files inside of it. You can also do some filtering, but we're not going to use that. Instead, we're going to pipe the output. That is, take the output of a process and feed it into a different process. So we're going to use the grep tool again, the Unix text search tool. And we're going to make the things going to search for that chunk of a file name. So we're lucky and we have found this. Now we're going to edit this file, and we're going to see if we can't see, if we're going to get rid of that sort of offending line of the program. Now, this obviously won't sort of fix the error, but we can determine if, say, that is causing the error or if the error is somewhere else. So, yeah. Let me like that. Right there, or tell me exactly when it's. Okay, now I'm going to basically, let me just make the wider then, because my head's not that wide. Okay, there we go. Anyways, we're going to use the enhanced version of Vi. This is a popular text editor in Unix. Now, Vi is a very keyboard-driven editor, but that's kind of its strength. It works sort of like SEU, but more freeform. So the strength here is that we have different motions, which lets you basically jump around according to a criteria. So we can jump around by words, we can search for things, we can jump by line, and we can even do things like jumping around by braces too. This is handy in C, for example. So then you can combine these motions with verbs, so you can do things like delete a word, like replace braces, and we can obviously undo that, and we and all sorts of different, basically, sort of criteria for basically making quick changes. Of course, you can work with them as you would in another editor by just basically inserting things and using your arrow keys. But like SEU, it's a lot more powerful when you use its command set. So what we're going to do is we're going to jump to that line that caused us problems. So if I recall, in the output, it was 2960. So we'll jump there, and this looks like it could be what the problem might be triggering it. So we have a case of the 64-bit integer types minimum value and maximum value. Those are often cases where, well, things could overflow if it's doing any sort of weird math with it. So since there's another code right below it that's using this, we're just going to replace this, and using the yank and then paste, we'll comment out this by inserting some text, and we will change the contents of the end of line here. So change to end of line. Then we'll write out 0, 0, 0, and see that. So we'll see if this maybe shifts around the error or, well, makes causes the error to stop. But again, of course, this actually doesn't fix the problem. It's just going to see if that's sort of a workaround if we want to see it compile all the way through. So we're going to build this again and see if that's changed the output. Now, because we changed this library, it might build actually a first time successfully and then the second time not successfully. The reason why is because the way Mono works here, where it builds a first version for bootstrapping that contains just the bare minimum of changes, well, bare minimum of files, and then builds a bigger version with that bootstrap copy. So it has all the features. So in this case, it's succeeding. Looks like the bootstrap copy. It might be missing that or building off of another bootstrap, but it's going to use this version now to make sort of a version that caused trouble last time. So looks like the error, but okay, another exception, but it looks like in this case it was a different error. It was 2 and 32 causing problems in a different line, but now it's 2 and 64 in a different line. So, okay. Now instead of trying to manually revert that change I made, we can actually use git to revert the change. We can use checkout command to basically revert the changes. Now checkout in git does all sorts of things. It can do everything from change branch to let you change to a specific commit, but you can also use it in this case to check out the file from a commit. In this case, if you don't give it a specific commit to revert a file to, it'll just pick the default, that is the version, the commit you're currently working with. So you can use this as a quick way to revert copies in your local working copy. So that's done. But if you'll notice, the class that's causing us trouble here is maybe decimal. That's the last thing on the call stack. So we're going to look for where the decimal class could be. So we know where the classes are, and we'll use the grep again, but give it a more general name here. So this is a little bit serendipitous because this looks like maybe it could be the decimal class. That comment probably suggests it is the decimal class. So we'll look at 2 and 32 because it was first error being caused here. So this is a reference to 2 and 32 when we search for it. Let's go to the next one. That's another reference, and well, that's 2 and 32 itself. So why don't we try to just quickly sort of trace what the D here is, that is the decimals passing into 2 and 32. So we'll just make a quick little right line statement. So system right line. And this is a newer C# feature, by the way. This will actually let you sort of include a variable into a string. This will actually compile into a string.format call for you. So, and that the D that is will automatically be inserted into that string. So we'll save here using W, and then Q to quit. Bye. Okay, now we're going to rebuild. Now it's also going to rebuild that version of a class that contains decimal. And so it'll also build a bootstrap copy and it'll build a normal copy. When it's using that bootstrap copy it builds out, it'll contain the change we made. So we'll build here. I'll just let it take a while to build here. Shouldn't be a minute. So now you can actually see where the change we made is being referenced. So all of the calls 2 and 32 are now including that statement in. executing it. So it's now going to build a problematic library before, and now it's going to use those 2 and 32 patches we made. So we can now actually see what value could be causing the error. So it's the same exception as before, but I don't know about you, but I think that's quite a bit bigger than what a 32-bit integer can hold. Well, actually smaller. So now, instead of trying to look maybe through the decimal class to figure out what could be causing the issue, we can actually use Git to see what changes have been made to the file. So we got to look at the Git log and see what all the commits that have happened recently. It's actually helpful enough to spell check me there. So what we can do here is look up, say, decimal. So we scroll up here. No. Okay. And what we see, oh my God. Okay. And find what the last commit. Okay. I do know this is the most recent decimal related commit. Sorry for jumping around there. I accidentally held the key too long. Anyways, so we can actually take a look at this commit. Now, if we run just git diff and this, it'll compare that commit to the most recent version, which we might not want. We just want to see what this commit changed. So, because that was basically that commit versus the most recent one. So, instead what we'll do is git diff. We'll paste that name in, but we'll paste that name in and include a tilde and 1. This will mean the commit before that. Then we'll paste the name of this commit in, which will then basically compare what changes have been made with that commit. So Git is also helpful in this to color code all the differences here. So new lines are in green and deleted lines are in red. So instead of trying to scroll through all this, let's just look up what decimal.cs says. Okay, so we can actually see what's different here. So we can see all the different changes made. So instead of trying to scroll through all the different lines here, I don't know about you, but when I think overflow issues, I think that could be endianness related. So endianness is a big concern here. So why don't we look up endian? And I think I see what the issue could be from here. Now, this is actually compile time conditional. C# has these like C does. So that actually is a compile time conditional. So if big endian is set up to the compiler, it'll compile this line. If it's not set, it'll compile this line instead. Or what this is here is a runtime check, so it'll be compiled to the same code, but the code just-in-time compiler will pick the right path as needed. What could be breaking this here is maybe Mono doesn't actually set this flag, but Core CLR does, or maybe a bootstrap copy that it's being built with doesn't have this flag set because it could be built on, say, a little endian system. So this runtime check is more appropriate. The good news is I've already determined that that is the case. I've actually debugged this issue before, and I reintroduced this regression to try and show you sort of how this kind of workflow works. So I'll just sort of revert that commit that caused the problem that I reintroduced, this one. So I'll run git revert instead of having to manually change all those references. That could be annoying. Okay, and I'll paste this commit in. Oh, looks like I actually have to revert the changes I made to that class because it would actually conflict with the changes that reverting would do. So again, we'll use checkout to revert the changes we have in our working copy back to the last commit made. So we'll check out and then we'll revert. Get revert here will actually not just revert it, but also make a commit and give us a message here. So instead of giving this default message, it's a little bit lame, we can instead write our own message, and this is actually using by here. We'll say fix decimal for Q user. Okay. Save and quit. And now we have a commit that's change 2 files to decimal files, and made all those commits. We also have a branch name here, and when we push this branch in, try and make a pull request with it. So we can actually say this is a real issue, and we could tell the project, well, why don't we fix this real issue? So we'll use git remote because I'm working with my own copy here. And Git is, again, decentralized and distributed, so the upstream isn't really aware of these changes until you push these changes to them. So as you see here, the origin is Mono's sort of master copy. I don't have write permissions to it, though, so instead I have my own fork of it on GitHub also. What I can do here is I can push these branches to my remote. I'll push this branch, and I have to log in with GitHub here. Actually going to push these changes, and now the outside world can see them. So the upstream really isn't aware of this yet. So let it upload, as long as I type the password to it correctly here. Okay, it's writing them out. And because we created a new branch for the first time, GitHub is actually nice enough to tell the Git client, say, why don't you make a pull request for this? Okay, I'll open up Firefox here. I'll paste that link it gave me in. And it's actually going to be nice enough here to fill in a lot of the things here. So at the bottom here, we can see the commits are made, what files have changed with it. Because the files are already been fixed upstream, it's not going to show us that diff because that changes will already been made. So it's already filled the branch title in here as the pull request name, plus the project itself has added some information inside the comment about how to make the pull request nicer. Now we won't actually make this change because this is just a silly little demo commit here, but it'll hopefully show you what they can do, how this sort of workflow is done. Now, after all of this sort of poured in technical stuff, I'm going to be talking about Mono, which you're kind of all here for. So the reason why Mono is so important is it's .NET on I. A lot of you have been wanting for years about this. And Mono basically supports almost the whole .NET framework. So you can run existing .NET applications. In addition, you can create new .NET applications too. A lot of people are already familiar with .NET, including people used to Microsoft tools or younger programmers. It's not just a Microsoft thing too anymore, where everything from Unity to Xamarin uses Mono behind the scenes. You can also use familiar tools like Visual Studio or Sharper, or Rider, or whatever you like, and you create C# programs that run on I. You can use libraries you're familiar with too, like say Nancy for creating lightweight web services. You also have full system integration here too. You have pinvoke or invoking native libraries on the system that run inside of page. You also have XML service and ILUsion for interacting with services on I, remotely or locally. For example, Mono could be used, for example, as a modern report generation system. I know you're thinking, I'm crazy here. Why am I suggesting this instead of RPG? But you could get your data from a database, for example, XML service ILUsion, but you could also say, make say, web requests or whatever you need to get more and more data in to collate and combine with. You can do your analysis and parsing using like techniques often used in C#, like LINQ, which lets you work with .NET collections and arrays as you would SQL or functional programming, and as any other sort of creature comforts you have. You can also use these libraries I mentioned, like EB+ for Excel, iTextSharp for PDFs, MailKit for email, and just make them all nicely formatted and place them into where they should be. Web can be a strength of Mono too. As mentioned, Nancy can create small web microservices, and you can usually use an Nginx, a popular web server, and reverse proxy to combine access to all these web services and secure them. In addition, ASP.NET is sort of in the works here. you can run existing ASP.NET programs, for example, things using MVC, and once its dependencies are sorted out, web forms. Mono is also improving its web forms implementation too by using the Microsoft's implementation and integrating that, which has recently been open source, so compatibility there can improve. If you have a native library in AIX or PACE, p-invoke is far simpler than JNI to use. It's just 2 lines of code. For example, that line there is importing from a C library, and there is calling the getProcessID function. Just 2 lines of code, whereas JNI would require you to create lots more wrappers. If you have an existing wrapper, but for a library that works on PACE, but the C# wrapper isn't sort of aware of what could be using, DLL map can actually rewrite references to that Windows library on the fly to the proper PACE library, as well as any function names too. If you have a library that's already running on AIX and PACE, then p-invoke basically lets you use a more ergonomic environment to work with than using C. For example, you have the span class, which lets you work with chunks of unmanaged memory safely and yet efficiently. To use Mono inside of PACE, you would just use it as you would on Linux or a Mac. You run Mono, the program name .exe. Yes, .NET programs are still .exe even on Unix, then any arguments you want to pass to it. You can also pass some environments, variables, or flags to the runtime itself, usually for debugging. Richard here has some nice examples of using Mono on I+ wrappers or CL, so you can actually integrate this into existing workflows and jobs. To develop for Mono on I, sure, you can actually use a compiler and build systems that ship with Mono on the machine, although the Microsoft C# compiler on I isn't supported due to an ending issue. Alternatively, you can just build from Visual Studio and copy it to the IFS and run it from there. This is a bit huge for Mono because you can just use the existing tools you're already familiar with to support I. Although .NET code is a lot more portable than basically your C code out of the box, things aren't perfect. You can still do a lot of the bit level manipulation with C# code. It happens less than I would say in C, but it definitely does happen. And you need to be aware of what NDNS you're kind of running on. Luckily, there's a .NET class that has a field that tells you what NDNS you're running on. So instead of hard coding it or whatever, you can just check it at runtime. Windows, the file system also works quite differently in Unixes than it does in Windows. The IFS is actually both case-sensitive and case-insensitive, depending on where the file is. For example, it's case-sensitive like AIX in the QOpen sister directory, yet case-insensitive like Windows and Macs and everywhere else. NFS, it depends on what the server is running. Path separators are also different. Windows uses a backslash, everything else uses a // and there's no drive let receiver. Line endings are different too. On Windows, it's a carriage return and line feed, or it's often represented in code as RN, RN, /R//N rather. On everywhere else, it's often just a line feed, or represented again in code /N. Of course, if you're using the ILE, then pretty much everything is in a database, so line endings are of no concern to you. The good news is, again, you don't have to hard code things here. There are classes built into .NET that basically lets you handle these differences at runtime and can automatically lift you of the concern of having to hard code and handle these yourself. For example, you have the path.combine class, which instead of having to concatenate strings together, you can just give it all the different chunks of the file name, and it'll automatically combine them and use the appropriate conventions. There are some cases where Windows-specific libraries can be incompatible too. If a program is using p-invoke to any Windows DLLs, it definitely won't work unless either of those calls are optional, or you can actually remap them to a PACE-compatible library. There are some things that are specific to Windows in the base class libraries too, such as WPF. These won't work unless somebody goes through the Herculean work needed to basically rewrite them. Parts of BCL will work, but porting them is a work in progress for I. This includes system.drawing or Kerberos. This affects things like the Microsoft SQL Server clients, although there are alternative clients that do work. As for how this Mono kind of started out here, January 9th, 2018 is when I started. Starting around early February, I could actually build all the way through. Although there were some bugs and working on that. In May, I wrote about it on the Mono website about, porting to AIX and I, and as well as explaining what I is to users who have never heard of I in the first place. In May, a member of the community also donated a petition for continuous integration on AIX. This has, again, been hugely useful in detecting regressions before they become problems down the road. So almost a day later, you can tell the upstream that, oh, hey, this code change you made might have broke something. And oftentimes, they might actually fix it themselves before you even have a chance to fix it. IT Jungle in October wrote an article about the report, and that brought a huge amount of awareness to it for I users. Well, a lot of people might be aware of sort of where .NET is heading and such. Might be wondering, on Linux, Microsoft is pushing Core CLR, which is their port of the original .NET framework to Linux. Does Mono impacted by that? And the answer is not as much as you think. Mono will stick around for a long time because it runs on several platforms Core CLR doesn't run on, often which are critical to businesses where .NET code needs to run on. This includes everything from game consoles, Xbox One, PlayStation 4, to a point that Sony even uses it as the base menu software. Nintendo Switch, mobile phones through Xamarin, for example, Android phones, iOS, tvOS, watchOS. There's also some other more obscure places. The RISC-V open source processor, WebAssembly, so you can actually run Mono code inside of a web browser. It runs on Z mainframes. It runs on Power Systems as well, both Indians of Linux. It even runs on microcontrollers now, so you can actually have Mono and sort of deep embedded where even Linux is too heavy to run. Now it runs on all AIX and I. Mono is also integrating the core effects, that is, the core CLI version of the base class library code into Mono itself. This will improve compatibility in the long term, even if there are some occasional regressions introduced as a result of this. Mono can also run existing binaries without recompiling, unlike Core CLR. But basically, I hope you all learned the sort of technical aspects of what it takes to port open source software to I. The sort of the limitations you have to deal with as a result of that. Also, the sort of social conditions that get into a sort of I as a hobbyist developer to even tried encouraging developers to port to it as well.